right, so I see there's already quite a few people in. I guess we might be seeing more people joining, but for the sake of time, and since we're 7 minutes in the slot, I guess we should get started. So hello again, everybody. Welcome to the 4th ChatDKG Open Office Hours, where we will be speaking a lot of interesting things, actually a very packed event today. And we're going to be having a special guest. Our friends from Milvus are joining us, and specifically together with us today, as you can see, it's Yujian Tang, the developer advocate at Zilis, which he will introduce, a vector database project based on, a rather platform based on the Milvus open source vector database project. And today we'll actually hear a little bit more about Milvus, and then we'll also see how you can actually build with it. So we have a tutorial ready for that. So I'll go ahead and start sharing my screen. But before we actually jump into all of that, so we're going to just quickly take a look at the agenda. And we're going to flip it over a little bit today. So we wanted to briefly introduce what ChatDKG is about. And actually we have a dev presentation that can only happen if it happens before 6. So we're going to flip it a little bit around. We're going to have the presentation of the ChatDKG builders. So if there's more of you that want to present today, feel free to raise your hand. We had one person want to present, but they need to leave before 6. So we're going to do it sort of in this order, and then we can do additional presentations right after, or even at the end of the event. But basically, this is what we're going to today. So we're going to go quickly through ChatDKG, the quick intro about it. Why are we here? Dev presentations. Then, as already mentioned, Yujian will take over and show us an intro into vector databases and basically explain what Milvus and Zilis are about. After that, we go deep into how that can be done, how that can be used with OriginTrail and Milvus together with Nicola, our lead blockchain developer, who will be presenting this case. We have also a short builders update for all the developers in the OriginTrail ecosystem. And as always, in the end, of course, room for open discussion for everybody. So without further ado, I'm just going to go ahead and give a quick intro on ChatDKG. Some of you probably have been here and know about this already. So very, very brief intro. Basically, the main pitch that we're trying to make here is that basically knowledge is a new asset class, and OriginTrail decentralized knowledge graph is all about useful knowledge. So specifically useful knowledge, we consider knowledge that can be shared, that can be verified for origin and in some regard authenticity, and can be discovered through certain mechanisms that are built into the protocol. So what we mean by that is a certain set of protocols developed on OriginTrail DKG. And I encourage everybody to take a look into all of the technical details that they might be interested in. Over the course of the years, we have amassed a lot of documentation about OriginTrail, what it means to be a decentralized knowledge graph. And today, we're basically talking about a framework that is being built out in the open together with the OriginTrail community, the entire project being built on 3 principles: neutrality, inclusiveness, and usability. From the inception, basically, is an open source system. We are building an open source framework together. And part of what you're seeing today, it basically becomes part of the framework as well. The core concept of the framework and the whole core concept of OriginTrail decentralized knowledge graph, basically the main building block, is something we call a knowledge asset. And in the previous call, we gave a more in-depth dive of all of the value propositions. So we're not going to go too deep into it today. We're just going to have a quick summary of what a knowledge asset is about. So basically, the applications built within ChatDKG and the one that we're going to be seeing today use this as the basis essentially of the entire knowledge-based applications that are built on top. So knowledge assets have these several value propositions that we'd like to just quickly recap. Knowledge assets are ownable, so you can create and own basically a piece of knowledge, and we'll see that today and how that can be done. This set of knowledge is then represented in a semantic form. This semantic form specifically in knowledge graph form on the OriginTrail DKG, but also how that relates to vector databases and the semantic capabilities they provide are something that we're going to be seeing. Like I said, Yujian is going to give us an in-depth guide. So if you haven't heard much about vector DB so far, you're going to get it right from the source, from the experts. Then when it comes back to knowledge assets, discoverability of knowledge assets is a big value proposition. We'll see some of that today, but essentially the idea of knowledge assets being that you can essentially search through them like you search to content for, let's say, through Google or even interfaces such as ChatGPT. So a lot of the new, let's say, upcoming interfaces are likely going to be more chat-like than, let's say, classic Google search-like. Though from the perspective of knowledge assets, that both, let's say, both paradigms, if you may think of that, sort of blend together. And we're going to show today one way how you can do it and get this type of interaction. However, with an application that applies extractive question answering rather than generative question answering, and that's what ChatDKG is actually all about. The idea is that we don't have some system basically guess really well what an answer to something is, rather that it actually finds the knowledge that corresponds to the question in basically a decentralized knowledge graph in a certain set of knowledge assets. When it finds these knowledge assets which an answer to the question comes from, the user or a system can actually verify this knowledge asset by verifying the provenance of this information, or rather the origin information and the update trail of the information on a blockchain. And you can see that because the record of ownership actually is represented by an NFT. Therefore, only the owner of the knowledge asset, the owner of the NFT, actually is able to manage and update, and in a way, at the beginning, you also create this knowledge asset. Having this NFT provides some very interesting capabilities, such as going further and exposing this knowledge to marketplaces, though we won't go there just yet on this call, but it's a very interesting topic. What we'll go into, though, is this use bullet, the last one, which basically enables us to do some very interesting applications based on knowledge assets. And we will showcase what it means, why we consider them being AI ready. For those of you who have been on the calls previously, you might have seen that we are very interested in exploring the synergy between knowledge graphs and large language models. And basically at the intersection of these two is where ChatDKG Framework is slowly but surely growing. And what we consider ChatDKG is really an open framework for efficient search, access, and utilization of trusted knowledge with AI. So basically, what we're looking to do altogether is to create tools that are based on knowledge assets and AI-based tools such as Milvus, for example, today. We want to see what are the best practices, how we can learn together in order to efficiently discover, access, query all of this trusted knowledge, how we can use it. And on top of that, we're also looking to how we can generate a large collaborative trusted knowledge base together. So that's also part of the ChatDKG framework. Towards the end of the call, I will also be mentioning a bit more, but there's a grant involved. You can apply to build your solution. It has to basically conform to certain standards, let's say, in order to be eligible, such as it has to be open source and so on. But without further ado, I think it makes sense to actually see one of those applicants in action. We've seen some of them on the several previous calls. I think 2 or 3 people have presented very interesting presentations, and they're moving along the application process, which is steered by the ChatDKG steering committee. And today, from what I know, I had one person approach, one project. But if there's any more, like I said, feel free to share. And that person is Milos. And Milos, I'm not sure if you're here, but if you are, it would be cool if you could raise your hand. And if we can give you, yes, there's the hand. So you know what?
Hi
I'm just going to
guys,
stop
can you hear
sharing my
me?
screen. Yes, hello, Milos, welcome. And we can see you as well. You have a really cool shirt, man.
Yeah,
black shirt day. Look, literally everybody has a black shirt.
That's right, yeah.
Awesome.
Okay, good. Yeah, I think now you can see me, you can hear me, which is great. So yeah, sorry again for like breaking the flow, but I have hard stop at 6. So yeah, I have to like leave in a couple of minutes, but let's quickly go over the idea that we iterated over. So I will share my screen and try to present the idea in the next couple of minutes. So I guess now it's on, you can see it. So, okay, yeah, so let's go straight to the point. So the idea is to basically create AI-powered CoPilot plugin for scientific research. So let's try to present that through a couple of examples. So imagine like doing some kind of research, which involves like a lot of different things, but among them there is a like step where you need to present some kind of overview within the field, where you need to list all of the important papers. Then sometimes it's important to compare them, to create some kind of comparison between the existing approaches and your approach. And also you need to basically cite all of those papers to like manage all of that. And the idea is to create a CoPilot plugin. What does it mean? So Microsoft will release soon assistants within all of their products, including Microsoft Word, which means that you will basically have an LLM interface that you can use for any kind of assistance. And the idea is to basically place and to first develop and then place such kind of plugin for Copilot that will help you conduct any kind of scientific research. So I'll basically show you like a couple of examples what that includes, but you can imagine like various kinds of actions that you can perform, like retrieving papers, retrieving results from abstract of the paper, or retrieving like reference papers, or like any kind of actions that you may need to easier conduct your research, since till that point, we are mostly conducting research by using Google and like literally going through the papers, trying to find referenced ones or influenced ones, and it's time consuming. So the idea here is to have an LLM as an interface, but since there is no room for hallucinations in general within the scientific research. So imagine like publishing something with artificial data inside you to LLM not being able to correctly predict a set of tokens or something like that. That could cause like a lot of trouble. So the idea is to use LLM as an interface and to connect that with DKG. So we'll have like a stateless connection between those two worlds. And by using LLM, a user could be able to retrieve or to request like any kind of info from the DKG, and also to retrieve proofs. And by doing that, we can ensure trustworthy way of retrieving data. So once we get something from the LLM, we ensure that it's not created by LLM, but it's fact from DKG, where a user can also like retrieve and verify by using LLM or on its own proofs. And the good thing also is, on the top of that, it can perform like different kinds of analysis, BI and ML in general. So this is a showcase that we did a couple of days ago, where we connected the LLM with the DKG and tried to retrieve some information from DKG. So let me guide you briefly through the components that we plan to develop. So there are like several layers that will be built on top of each other. So one is knowledge retrieval. So the idea is to access scientific papers information by querying the DKG through LLM. So there is no need to be familiar with Sparkle or like any other query language. You just need to basically type the query, and you will get a response from DKG through LLM interface. Then on the top of that, we'll build a text to Sparkle component that will try to retrieve more complex answers, like some kind of analysis, like grouping or indirect references between papers, or some summarizing impactful papers in some field, or any kind of request, including complex data retrieval. Then on the top of that, what we can also do, it's inference. And it's important to know that it's inference over trusted data. So we retrieve data from DKG, and then, for example, we can cluster data by fields. We can do some kind of similarity checks or something like that, and then ship it to the end user, which may be quite useful, like discover areas that are not so saturated for further research or something like that. So I think that all of those components can improve user experience while doing research, and also save some time. So all of those components should help end users basically try out the integration between LLMs and the decentralized knowledge graph. And the idea on this project is to basically see what we can get from all of those components, and what are the limitations that we may encounter. So that's an idea in a nutshell. And yeah, like the main benefits there is to ensure like a trust way of retrieving data, and also using LLM as an interface, so speeding up the entire process. So we listed here like a couple of user stories that we would like to cover. I will not go into detail since we have like limited time. Just one note on the data retrieval. So there are a couple of APIs that we can use for scientific paper information retrieval. Among them, there are some public ones. Also, I got access to the Semantic Scholar, which seems like the best fit, since they already have some kind of AI on the top of data, and they have data in the graph format. So the idea is to pull data from that source, store it within the DKG, and then see what we can do through LLM interface. So yeah, that would be pretty much all from my side.
Awesome, Milos. I'm trying to read the user stories. It looks pretty slick and tightly defined, and yeah, especially like the example you showcased with Professor Bob Metcalf and his research paper. It's going to be really cool once we can try to do this. I'm excited to try it out myself. So really interesting. Anybody? Yeah.
Yeah. So regarding that, like demo, so it's still like under development, and it's working locally. But soon I plan to make it publicly available. So the idea is to host that on one of the public servers, and that anyone could try, and also like open like any issues on the GitHub repository. So we create some kind of feedback loop where we try to like tackle as much things as we can within the scientific research field.
Awesome. Anybody have any comments or wants to just shoot the kudos or whatever? The time is now, because I think we have a few minutes left with Milos.
Yeah, no, I like it. I mean, it looks promising. I can't wait for the demo to start playing around.
Yeah, very good, very exciting stuff.
Awesome. Thanks a lot for joining me, Milos, and for showcasing. So from here, we basically take you forward, and we're going to dive deeper into the spec that you provided. And we're still doing reviews with the rest of the applicants. So there's actually quite a few applications. And I'd like to actually encourage everybody who's sort of thinking of applying or maybe being slow, trying to perfect your application. Just encourage you to sort of, go ahead and do it because there's already quite a lot of interest and quite a lot of people building something. Makes sense that, even if it's not perfect as an application, you can get some early feedback from the steering committee. You can also use these calls to get feedback from the community as well. So basically, those two tools are available to make you sort of go quicker through the application process. And yeah, also it's an opportunity to meet other builders and potentially join together and apply together to build ChatDKG apps. Maybe one more thing, instead of because there's been applications that have been a little bit, on the how do I say it, on the bigger side, like a bit more monumental, or trying to do maybe a little bit too many things at the beginning. A suggestion for everybody is to try to chop it up into smaller pieces and apply with something smaller first, and then you can then see if it works, if it goes through and has traction. There's nothing stopping you from applying again. So all right, thanks again, Milos. Thanks for coming and joining and presenting. And I guess we take it from here. So I'll just take one more moment to give a summary of what we just talked about and why this is part of the program. So within ChatDKG, you should see my screen again. Yes, you see it. We basically identified 4 high priority areas, which is semantic search over knowledge assets, natural language querying over DKG, which is somewhat of the basically category that Milos has presented just now, AI-based knowledge publishing tools, so basically ways to create knowledge assets. And you can see some examples here under each of the categories, and kind of a general category, so general AI system integration. Basically, the criteria for ChatDKG for you to be eligible for applying for a grant is to create something which is open source. Obviously, publicly built project has to apply to knowledge assets, of course, has to solve some meaningful problem, and it implies active development and engagement in our community. So through these calls, through Discord, through communications with developers, the idea is that this is a learning experience for everybody. So both for the builders, also for us, anybody coming to this call. These are generally the high level, very, I would say, relatively simple criteria that we're looking to. Now, we have a special guest today who is actually going to show us something that applies mostly to, let's say, the first category here, semantic search over knowledge assets. So if you have been thinking about building within this category, such as this example, knowledge asset vector similarity search tools, you'll get to learn much more about vector database, about Milvus, which is one of the leading vector database applications, another open source project, which is why we have established this relationship. We are very big on open source at OriginTrail. And we're going to learn more about what they do and how they do it, what vector DBs are, from the developer advocate at Milvus, Yujian Tang, who is available here today to teach you all of the cool stuff. So I'm going to stop sharing my screen. I'll let you, Yujian, take over and present, showcase essentially Milvus and your presentation.
Cool. Thank you very much, Branimir. Let me share my screen. Do this. Can everybody see this? No. It says no. Okay. Oh, my
It's still black.
It's having me sign back into my Google account. I guess it logged me out earlier.
That's fine. Take your time.
Let's see, where is it? Can you see it now?
Yes.
Everybody can see it? Okay, cool. So thanks for coming out today. I'm going to be talking to you guys about vector databases. I'm really just going to be giving an introduction to vector databases in general. So my name is Yujian Tang. I am the currently the only developer advocate at Zillis, but if you are interested in what we're doing and you like what I do with this kind of giving talks, creating POCs, and working with LLM apps, you should consider applying because we are looking to hire for DevRel. And this is how you can reach me. If you have your phone, you can scan the QR code and you can contact me on LinkedIn that way. I'm most active on LinkedIn. A little bit about my background before we get into this. I've been in software for a while. So I started my software career working at IBM. And then I went to college and I did some machine learning research and I published a few papers. And then I went to work at Amazon as a software engineer. I worked on their AutoML system. And then I left and I got into the startup world. I created a couple of my own companies. And that's kind of how I got into developer advocacy. Is I really found out that I enjoy this content creation. I enjoy really working with like cutting edge technology, such as these LLM frameworks like Llama and LangChain and Milvus. And since I've been here, I've had the opportunity to work on a lot of these cutting edge AI ML projects, and it's been really, really cool. So let's get into it. Let's talk about Zillis first, and then we'll get into it. Okay, so here's how you can find us at Zillis Universe or on LinkedIn, or if you want to join the Slack, if you have questions on Milvus. Milvus is the open source project. Zillis is the company that maintains this open source project. My primary job here is to talk to people about vector databases and Milvus, but really push vector databases in general because we really believe that these are going to be an integral part of the stack for LLM apps and for things such as ChatDKG. So today I'm going to cover, basically, I like to give two forms of presentations. One is problem solution and one is why, how, what. And so we're going to start with this one. Today, I'm going to do a why vectors, like why do we care about vectors? How do vectors work? Like where can you get them and stuff like that? And then what is a vector database? And then we're going to go into use cases for like ways you can use a vector database or ways that people are currently using vector databases. So step one, why vectors? Unstructured data is everywhere. And unstructured data is a kind of data that doesn't have a predetermined or predefined model to it, right? So for example, if you have like a Wikipedia page, that's technically unstructured, like sure, there's some sections here and there, but it's not always the same. And most of the time it's actually not the same. And unstructured data, I would bet that many of us have heard this term, this phrase that 80% of data out there is unstructured data. And as we grow, as we have put more and more data out there, more and more data is going to be unstructured data. The types of data that count under this category include images, videos, text, audio, chemicals. All of these different things count as unstructured data. The only thing that is structured data is something that you can put into like a SQL database. Okay, so how do we where do these vectors kind of come from, right? Vector embeddings are generated through deep learning models. They're generated from your data or any kind of data that you have, and they go through a deep learning model to turn into a vector. And so this is important. This becomes important when it comes to choosing the models that you use to generate your vector embeddings. And the things that I want to point out here basically are when you are working with vectors, you want to use the same model to generate the vector embeddings for putting your models into your database as you do for querying your database with your search data. Also, you want to make sure that your model you're using models with the same dimensions. You want to make sure you know how many dimensions are in your model. That's going to be basically how many dimensions are in your vector. And the way that this generally works is you take your data, you throw it into a model, and you cut off the last layer. So the last layer of a model is usually like classification or prediction or something like that. But if you take the second to last layer, then you're going to get the vector embeddings. And I'll show another diagram about this later. And you get some sort of vectors and you put it into Milvus, and that's how you start working with these vectors. Another reason why we want to use vector embeddings is vectors basically allow us to do math on words or math on images or math on something that is not necessarily something that we would initially intuitively think of as a number. So in this case, this allows us to do things. So the image is, I'm just going to describe this image here. You can kind of take a look at the image. You see that queen, king, woman, and man are the four words that we have here. And what I want to point your attention towards is the first number in queen and woman in the representations. These are the vector representations, these two numbers here. The first number in queen and woman is the same, and that means that they are semantically similar along that first dimension. And you can also see that the same thing applies for king and man. And the difference between queen and king on the second dimension, the second number, and the difference between woman and man on the second number is the same. You see how that's 0.2 right here? 0.9 minus 0.7 is the same as 0.4 minus 0.2. So what this allows us to do basically is to do some math on these words. So if we take the word queen, we start with 0.3 comma 0.9. By the way, if I'm not being clear about this, just like drop something in the chat and be like, can you repeat that? Can you go over that again? And I'll cover it again. So we start with queen, and we're going to subtract the word woman. So we have 0.3 comma 0.9, and we're going to subtract 0.3 comma 0.4. And now we'll have 0 comma 0.5. Then we'll add man to that, and we'll have 0.5 comma 0.5 plus 0.2, which is 0.7, and we get the word king. So what we've just illustrated with these vectors is that you can do queen minus woman plus man is king. So the semantic similarity here shows that these are the same. Okay. Very interesting. Keep going. Thank you. That's not really a question, but I'll take it. So yeah, that's kind of like what we want to illustrate here. And in this example, I use Euclidean distance, which is something you would never actually use. And then this is a very like toy example. There's two vectors. There's a two-dimensional vector. Normally, we work with 384, 768, or 1536 dimensional vectors for text. So this is like a very, very much just a toy example. How are these generated? Right. Wait, what was my next slide? Let me just check here. Okay. As I was saying earlier, these are generated in this second to last layer of a neural network. So this is just a bigger image to demonstrate to you what a neural network kind of looks like, right? You have some inputs, and usually with text, this is going to be some sort of tokens or something maybe like a one-hot encoding, something like that. And then you just run it through. You run it through the neural network until you get to the second to last layer. And then you cut off the output layer and you just take the outputs of this hidden layer here. So these four like little, arrows that we pointing towards the red dot are now actually the numbers that you're going to take out. And that's going to be what your vector embedding is. And yeah, the dimensionality of your vector embedding is basically equal to the number of nodes in this layer. And because of the way these are generated, I often get asked, people will often ask me like, what do each dimensions in vectors represent? And the answer is nothing. They are very, very high level abstractions that are created by a neural network. So they actually don't mean anything concrete. They are just saying like, hey, if we put this word in 784 dimensions, here's what it would look like, which, doesn't really make a lot of intuitive mathematical sense, but works really well when it comes to generating these high dimensional spaces, because it essentially allows for high dimensional reasoning, which is very similar to human thought. Okay, so how does similarity search work? This is the basic underlying power or value prop of vector search libraries. And this is kind of what sits on top of a vector database. This is like the unique value proposition that a lot of people kind of look at before they really look into, do I need a vector database? So for some cases, you actually don't need to go to a vector database. You can just use a vector search library. Vector databases are more there for if you want a scalable solution that includes other things on top of it, such as security, access control, multi-tenancy, these kinds of things. But the basic idea behind how semantic similarity works is you take some sort of unstructured data, images, videos, documents, audio, whatever, doesn't matter, and you transform it into a vector. So like I said earlier, you're going to have to find the right model. So for example, if you're going to do text, you probably want something like sentence transformers from Hugging Face. Or if you want images, you probably want like ResNet 50, something like that. Transform that into a vector and you store that into your vector database. And that's all you need to do to store the vectors. That's it. That's step one, or it's step 1 and 2. But that's how you get into the vector database. Next, what happens is you start querying. And when you query, you come and you bring some sort of input data, like something you want to search for, and you run it through the same model that you used to get your vectors from before. Make sure that this is the same model, or if it's not the same model, at least make sure it has the same number of dimensions. Will you get the same results if it has the same number of dimensions, but it's not the same model? I don't think you'll get as accurate results, but this is something that you can play around with because you can fine tune these models. Up to you. I actually wrote a piece about this recently about comparing like the vector embeddings from multiple models and kind of like seeing the results that you get. And then once you do that, you perform some sort of approximate nearest neighbor similarity search. This is what we call a vector index, and then you get your results. I have some slides about the vector index towards the end, like in the appendix, and we can cover those at the end if you guys want. If not, they're pretty math heavy kind of stuff. And I also want to show you what a vector embedding looks like. This is a screenshot that I took directly from Zillis Cloud. I went to Zillis.com and just like spun up my collection. This is an example collection. It's a bunch of Medium articles. And basically what I want to show you here is basically like, this is what the vector looks like. It is literally a list of numbers. It's a list of floating points. But inside of Milvus or inside of Zillis, you will also have things such as metadata, and you can store things like the title, the link to the thing. There's also like author, the publication, many more things you can store in here. And the reason why we have this metadata filtering is because on top of just vector similarity, you might want something that allows you to filter on vectors. For example, maybe I just want the Medium articles that are published in and published in towards data science or something like that. Then what I can do is I can put that into a filter and I can search and I can get that back, right? Okay, so now let's get to the part where we talk about what is a vector database. Here at Zillis, we define vector databases as a database purpose-built to store, index, and query large quantities of embeddings. And the reason why we have this is because Milvus is actually particularly suited towards very, very large quantities of embeddings, such as billion scale embeddings. And we are one of the only vector solutions that do this. And the reason why we are able to do this is because we have taken the conscious decision to invest in technology before we invest in awareness. So, people knowing about us is really great for us, but really we focus on building an amazing product. And Milvus has a distributed system cloud native backend. And I mean, we can get more into the tech if you guys would like. I can answer questions about it later, but I think it's really cool. I'll cover a little bit of it in a second. And so this is the architecture. This is the distributed system, like cloud native backend that I think is just awesome. So in many ways, this allows you a lot of flexibility and B, near infinite scaling. So the important parts to notice here, I mean, like any database, Milvus is a real database. So we have a write-ahead log and we have streaming data for that, right? But the really important things to notice are these like nodes and how they work. So Milvus has 3 nodes to it. And these nodes are a query node, a data node, and an index node. And the index node is just for indexing. And you almost only need this like once every project. There's very rare cases where you will re-index. The reason why it is very rare that you will re-index on Milvus is because we create all of our indexes over 512 megabyte segments that once it reaches that segment size, we don't put any more data in there. And so this is also what makes it scale really well is because let's say you have 200 gigabytes of data. Would you rather parallel search 400, 512 megabyte segments or serial search 200 gigabytes? The answer there is pretty similar. I mean, like one is log scale, one is linear scale. You want to go log scale, right? The other thing about this is like, these 2 nodes here, the query node and the data node. The query node is really the heavy lifter. If you are going to be doing a lot of querying, if you have a high query per second, your query node is going to be doing the heavy lifting. And so what you might want to do is you might want to scale up your queries. You might say, I want to query this thing 300 times a second. Let me get 300 actually is pretty regular for Milvus. You don't need too much scaling for that. 30,000 times, then let me scale up my query node, right? And so what you can do is you can create replications, or you can have more memory, more RAM into one node, right? And then the data node is basically handles the ingestion of the data into your collections, into permanent storage. And so the reason why this is different than what you see in other architectures, and if you look at the architecture of other vector databases, you'll actually see that they commonly have one node. They don't have these 3 nodes that allow you this kind of like different scaling, which is something that I think is just like really awesome about Milvus, really cool. And Zillis allows you to kind of pick the way that you want to scale these nodes up by allowing you to do performance optimized, cost optimized, or capacity optimized. And Milvus, you can kind of manage this all yourself. Okay, let's take a look at some use cases for vector databases, because this is basically these are the basic use cases. These are the biggest use cases. These were what I consider to be like the classical use cases for vector databases. This is what people were using them for before LLM apps came around and were like super popular. LLM apps are like the popular new kid in town. But before that, it was used on Similarity search for a bunch of things: images, videos, audio, text, DNA, molecules, for recommender systems. Actually, recommender systems is one of the biggest use cases for vector databases prior to this LLM thing. So I'm just going to show 2 examples. I'm going to go deeper into 2 examples. So number 1 is product recommendations. You can kind of see this is what this looks like, right? You have a name, which can be vectorized, an image, which can be vectorized, and probably description, which can be vectorized. And what you can do is you can say, hey, I'm looking for shoes that are kind of like this. Find me the closest examples, and this is what it sends you. And the price is also vectorized. You can see there's all similar pricing as well. So for product recommendations, basically you're just looking for the closest vectors along some segments and then returning those. And so you can do this either by having multiple collections or by having a multimodal model or something like that. The most recent addition of, or the most recent, I guess, like popularity of LLMs has shown us that there's a couple things that LLMs do poorly that vector databases are really well suited for. And this is why we believe that vector databases are going to be such an important part of the upcoming new paradigm for building machine learning applications, especially with large language models. Large language models face they face many problems, but one of those is data. One of those is either they don't have the updated data or they don't have your domain knowledge data. And that's where ChatDKG comes in, right? You can use ChatDKG or like a vector database kind of thing. You can start injecting data to your LLM so you can get the right data. You don't have to ask the LLM to make up things, to hallucinate. And you can start using that to create these LLM apps, and you can use that to create internal LLM apps. And one thing I've seen a lot is people asking how to do this with their internal documents. Some examples of tools that you can use with this are GPT cache, which is basically a semantic cache that if you ping GPT or whatever a lot with similar questions, for example, if I ask, how do I query Milvus and how do I search on Milvus? These are basically the same question, but they aren't actually the same question if you look at it from a keyword point of view, but semantically, these are very similar. And it would be dumb to use the LLM to, kind of query this twice. And so you can save costs by just querying these, by just using a semantic cache. The second logo here is the logo for Llama Index. I don't know if you guys have heard of that, but that's a framework used for building LLMs. It is one of my favorite frameworks. It's really nice. It works on data. It works on how do you index and how do you access your data. This third picture here is OSS Chat, which is an example of an application that we built here inside Zillis that allows you to chat with open source software. I recommend you check it out because you can kind of play around with it and you can ask it things like, what is LangChain? And it'll give you an actual answer. Whereas if you go to ChatGPT, you ask, what is LangChain? It'll be like, I don't know what LangChain is. I'm only trained until September 2021. So yeah, that's kind of how you can add data to LLMs with a vector database. And one more thing, this is just like a literal example is just like, let's say you're a company, you have hundreds of thousands of pages of proprietary documentation, maybe you have millions of pages, you're a big company, you're Amazon, something like that. I mean, like, I don't know if you guys have worked at big companies. I've worked at big companies, and sometimes you just search things and you're sitting there for like 3 or 4 hours. You're like, I found this wiki, half of it's filled out, and it was updated 5 years ago. And like, like it's not great. And then you find out like a couple hours later, oh, there's actually an updated version of this document. Wouldn't it be nice to just have that in a chatbot where you can say, oh, what is this? And give me the most recent version, and then they'll give it to you. And then, that's like you save 5 hours out of your day. So this is like a legitimate problem that a lot of enterprises are facing, and they are trying to build these internal multi-document query engines. And so this is something I see a lot and people ask a lot of questions about. FAQ, I'm just going to go over this real quick. CSV files. Some people will try to read CSV files into Milvus, and they say, hey, I'm having problems finding the right CSV return value. And then I say, okay, what are you using for your embeddings model? And they say, oh, I'm using sentence transformer. Okay, problem number 1, sentence transformer is trained on sentences, not CSVs. So remember to use the right type of embedding model. If you want to use a vector database, make sure that you are embedding with the right models. Role-based access control, people ask for this a lot, especially enterprises. It's on Milvus, it's on Zillus, it's there. Scaling up and down, people also ask about this, especially when it comes, especially larger companies, they come and they ask about scaling up and down. We do not auto scale because we do not want to charge. Zillus Cloud does not auto scale because we do not want to charge you for resources that you're not using. But scaling down is actually a kind of a tough one because you have to keep enough memory to actually load all your data. So depending on how much data you have, it might not actually be possible to scale down. But this is something that people from Milvus have asked. And with Milvus, you can do this as well. It's not as easy with Zillus Cloud. It's one click. With Milvus, you have to go and provision your EC2 instances or whatever by yourself. Hybrid search. So there are 2 things that people mean when they say hybrid search. And one is searching across vectors plus some sort of metadata filtering, which is what we offer. And then the other one is searching across vectors plus some sort of keyword search, which we don't offer. And we would suggest that you would use something else in conjunction with Milvus, such as CockroachDB or some sort of SQL database to do that. And then when do we not want to use a vector database? If you never need to compare how similar things are, don't use a vector database. You got a user management system where you just care about like your users and their passwords have to be exact matching. Use a SQL database. There's no reason to use a vector database. Vector databases are basically just for similarity search, and they're cool and they're like a hot new technology. But just because they're hot new technology doesn't mean you should apply them to everything. There's no need to apply them to like a user management system. Yeah, if you have any questions, I'll take some questions. I believe this QR code goes to Milvus. It might go somewhere else. But yeah, check it out, give it a scan, go to Milvus. If you like the project, give it a star because the company cares. Yeah, and then I can also go over some indexing if you guys want to hear about that. Otherwise, I'm open for questions.
Awesome, thanks a lot, man. Actually, yeah, well, maybe we start with that. Any questions so far by anybody outside of the one that was kudos, I guess, by Tyler? Feel free to type them in the QA section. If not, I'm curious about the indexing. If you can spare a few more minutes to show us a bit more about that.
Yeah,
that'll be awesome.
Okay, cool. I can talk about the indexing. So Zillus offers 9 indexes, but I'm only going to cover 3 of them here, okay? So number 1 is approximate nearest neighbors. Oh yeah, this is called Annoy. This was a indexing method out of Spotify. This is an approximate nearest neighbors method that Spotify uses. And what it essentially does is it takes your high dimensional space and it takes 2 points and it says, okay, these are 2 random points in the space. I'm going to come in the middle. I'm going to draw this hyperplane. And this is going to be split number 1. And now you have binary tree leaf 1, binary tree leaf 2. So, if you understand how binary trees work, right, you're creating binary trees out of your high dimensional space. Essentially, you create like some sort of large dimension tree, large decision tree, right? So you start with step 1 and then you go into leaf node 1 and you do the same thing. And then leaf node 2 and you do the same thing. And you just keep doing until you have a binary tree where you have some number of nodes at the end that contain maybe 5 vectors, 50 vectors. I don't know. It's a hyperparameter that is up to you to tune. And so, as you can imagine, This is an index that's actually pretty efficient. It's not a huge index. The index itself is not bigger than the number of nodes that you have, or sorry, the number of entries that you have. And it's a decently good performing query. Now, one of the problems with Annoy is that the recall is not amazing. It is good, but it could be better. And we'll see an algorithm with a much better recall in a couple steps. Next is IVF, or inverted file index. I don't know why they call this IVF, because like the V is not capitalized and inverted. So weird naming convention, but this is basically a k-means clustering. So what happens is you get your high dimensional space, you have your vectors all over, and then you select, maybe I want 20, and then, it does the k-means algorithm. It says, okay, here's your 20 random centroids, and now we're just gonna, do all the calculations until we get it right. And then you have your 20 centroids. And the way this works at query time is, so the way that Annoy works at query time is it checks the binary tree. The way that IVF works at query time is it says, okay, here's your 20 closest centroids. Here's my query vector. Let's first find the closest centroids. And then inside of these centroids, there's going to be maybe hundreds of vectors. Let's compare those. And so you can imagine that this is also a much more efficient method than, querying the entire space, because vectors require a lot of computation. And it has decent recall as well. It's good recall, good index size, but can be better. And so we'll see something with a much better recall, and that's
Yujian.
Yes.
Sorry to jump in like this, Ken. While you're at recall and precision, can you maybe give an intro for the folks on the call? Because I believe not everybody. We have, like, let's say, folks from the blockchain world who might not come into touch with these concepts so often. So can you give us a quick explanation? What do you mean by recall, precision, and these metrics?
Yes. So in vector search, recall is a method that basically says, okay, if I have, let's say I have a vector search and I get 100 vectors back, how many of these vectors kind of like do I expect to get back are really in the right order? And the reason why you have to deal with this is because of these indexing methods where you may actually get, so for example, let's say your vector is like right here. Now you're in a tough spot because you got a bunch of centroids that are close to you. So you may not always get the exact closest vectors returned because it depends on the parameters that you use to search. So that's what I mean by recall, is how much out of 100 vectors that you get returned back, how many of those 100 vectors are actually match the actual closest 100 vectors. So HNSW will give you a 99.9% recall. The problem with this one is that it is a graph index, so it's a huge index, but it's very popular, and it's very popular because memory is cheap now. But the way this works is basically at ingestion time, at creation time, every time you create a graph where every node, every vector basically points to its closest neighbor. And the way this works is as you add nodes to the graph, you're going to come up with every node gets assigned a uniform random variable. And then based on a uniform random variable, it gets to be put in layer 0 or 1 or 2 or 3 or 4, depending on whatever it is. So for example, if your cutoff is, for your uniform random variable is like, let's say 90%, that means that if you generate a number between 0 and 0.9, you go into layer 0. If you generate a number between 0.9 and 0.99, layer 1, 0.99 and 0.999, layer 2. Between 0.999 and 0.9999, layer 3, and so on and so on. And so HNSW actually is non-deterministic because of this like random number generation, but it does offer a near perfect recall. There's only one search method that actually offers 100% perfect recall, and that is just brute force. But this is the closest that you can get while still having an efficient and fast query time. So these are the 3 indexes that I typically talk to people about because these are the 3 that really matter.
Awesome, great stuff. That was really, really interesting, the entire presentation. Looking into the QA, I think people are a little bedazzled. So that was cool. That means, I guess, a bunch of people learned a lot of things today.
I hope so. I hope it doesn't mean that I lost people. I went too fast or something. Sometimes that'll happen too.
I'm not sure. I don't know. I couldn't say. I managed to follow. It was very interesting to me. I also learned new things.
It's also recorded, so you know they can put it on 0.5 speed afterwards as well.
Hierarchical, navigable, small worlds. Very slow.
Oh, cool. Oh, very informative. Thank you, guys. Oh, Tyler has a question. I think this is up to you guys. With the DKG search use HNSW, this is for you guys.
Or is that up to the user? Actually, yeah, that's a very good question. I can address it relatively quickly. But essentially, the vector similarity search capabilities that the DKG employs right now with you have the ability to build knowledge asset applications with tools such as Milvus or Zilis. So at the moment, you use basically the indexing you choose to when using these tools. However, and that's one thing that is sort of briefly mentioned so far. There is essentially a plan to enable a way to create basically a decentralized index of knowledge assets, in the sense that this indexing information is also implemented in and owned by whoever runs the system. So let's say multiple people run their Milvus instances, they could actually share through the OriginTrail protocol a way to perform queries on top of the knowledge assets. So this is in the domain of R&D essentially, and there's going to be an OriginTrail RFC created for that when the time is right. So Tyler, when that is up, where we can definitely chat more on that. But it would be very, very interesting to go into, and we would be definitely also looking into how we could have Milvus be part of that. I have another question actually. I'm not sure if you managed to follow the previous presentation from one of the builders in the ChatDKG space, but basically they're looking to create a CoPilot plugin for OriginTrail. Which is set on a specific domain of knowledge, which is scientific research, I think, at the beginning. So in a way, the question would be, do you have any sort of, let's say, could you maybe explain a case from that perspective where Milvus could help, let's say, this person or such a project, how that would work for them? And then we can also jump into an example of very simple hello world Milvus plus OriginTrail after.
Sure. Yeah, if you want to, add this kind of like scientific knowledge onto some sort of app, and if you put it into a vector database, okay, so there's actually some nuances here, because a lot of these documents that people are like scientific research, particularly, seems to have a lot of unstructured data that is a little bit difficult to handle. So 1 is graphs, 2 is images, 3 is equations. But if you can get these vectorized well, then it's fine. And you can chunk your data, you can chunk your documents, and you can put it into Milvus, and it will do a vector search on them for whenever you need to get it back, whenever you query, basically. But yes, there are some challenges in there, but I think those are challenges that you would face whether or not you're using a vector database for this.
Yeah, that's a very valid point, and it's this classic, basically classic information retrieval problem revolves around all of these things. And what I really liked when your presentation is how essentially you really nicely explained something very complex. You said basically, if you're looking to have a similarity search application, then it makes sense to use vector DBs. Otherwise, go ahead and use SQL. We have kind of a similar principle from the get-go of OriginTrail becoming a decentralized project, where at the time, 2017, there was a lot of talk about using blockchain as kind of a be-all, end-all database. It's gonna solve the world, and it's gonna take your kids to kindergarten for you, and all these promises that were there. But essentially, the sort of the pitch always seemed weird, because it's a very, very constrained database, even if you may call it like that. Rather, it's more of a ledger. So it really makes sense to use the right tool for the right problem. And at Trace Labs, the core developers of OriginTrail, we're really, really happy to be exploring all the new capabilities that the vector databases, the magic really that they bring. So it's really cool to learn more about them today directly from you, and to have this opportunity to host you on the ChatDKG open office hours. All right, I see a couple of comments that it was amazing, very informative. So people giving really positive feedback. I guess, does anybody on the call have any more questions, or can we proceed with the demo?
Yeah, let's do the demo.
Let's do the demo. I agree. So thanks again, Yujian. We'd be happy to have you stay with us if you can. But if you cannot, feel free to go. We're just gonna introduce what we're gonna demo.
In case you did drop off, it was a really cool presentation. I enjoyed that.
Thank you. I'm glad.
Absolutely. So very simple architecture block scheme of what we're going to be looking at. So we've seen vector databases, and basically Milvus being one. So here it's called vector index. Actually, let me change that. Live on the call will be vector DB instead. So let's see if that works live. No, it doesn't. Or now it does. No, it doesn't. Okay. Why not? So yes, vector DB. So what we're seeing here is a very simple, the simplest possible block scheme, because we didn't want to complicate it. There's obviously more details in it. But what we're going to see is a combination of using Milvus as the vector DB and OriginTrail DKG, knowledge assets in particular under the hood, with a client basically for the DKG in the application level. So we're going to showcase a very simple hello world-like trusted semantic search app based on basically textual information. And Nicola can go ahead and take it away. I just wanted to share this one slide for you so you guys get some context. Stopping share right now.
We can't hear you, Nicola. Yeah. But you're also not muted.
Let's test.
Yeah, now we can. Yeah, now we're here.
Awesome. And I hope you see also my screen. So
yes, we do.
Let's kickstart. So as Brian said, we have one new example here in our ChatDKG repository, just to show you, like, to give you some kind of inspiration what you can build on DKG. And this one example is combining the DKG and the Milvus vector database. And it's quite simple, so less than 200 lines of code. So 2 files. One will be the create demo knowledge assets by. This would create knowledge assets and vectorize them as it's shown on previous presentation. So it's the left side of the flow where we create everything, create the embeddings and upload them. And then the second part is searching it. So defining what we want what's the question and how we can search for the answer on the DKG. So I can jump now directly into the code. So here you can see the first file is that create demo after importing some dependencies, and we will have the example of you may curl the imaginary medicine leaflet content. So the data set looks like this. It's a digital document and it has some titles and sections. Different sections present like what's used for, what you need to know before taking it, and so on. So that's a nice example of a document that can be turned into knowledge asset and can be published on the DKG. And as the first steps, we would prepare like the node and blockchain providers for the connecting to the DKG and to the, in this case, OriginTrail Parachain testnet. And if it initializes DKG, we can just with one line create the asset by providing the example JSON LD that I just showed. So we are creating it, and I will actually start and let it work. So at the moment we will see the result would be the URL or uniform asset locator. And yeah, so here when we create and when we have the URL, next step would be some preparatory work. So preparing the data set just for format that is easily uploadable. So the moment we prepare all the data, we will establish connection to the Milvus. As I said, we are using the Zilis hosted Milvus database and providing all the information, creating the bandings with only one command, vector.db. We are adding this document and creating it inside of the vector.db. So I would expect any second here to finish the knowledge asset creation of the network. So yeah, okay, while we wait also for it. So okay, yeah, here it is. So we have the knowledge asset URL, and you can see it's on DKG. Here is the ID of the asset, and the second line, it was the loading for the upload of the asset. And now, as we have the knowledge asset on the DKG and also in the vector.db, we can perform the searching, and it's also quite similar. After establishing connection to the database, we are here like looking what we can ask for. And for example, one question could be, can I drink alcohol when I'm taking Umicrol medicine? So this would be like calling the vector.db and performing similarity search. So I search by here it is. So after it loaded up, so we get the responses as they also exist on DKG. So content from the page one would be like this question, what you need to know before taking Umicrol, and also like possible side effects. So these are all like the relevant parts of the knowledge asset that we are getting here as an answer. And even more, next step could be we can plug in all those answers into, for example, OpenAI or other plugin and make it summarize the response. So like if we summarize it here, we will see that quick short response would be, no, you should not drink alcohol while taking Umicrol. Drinking alcohol will increase your chances of getting side effects. So yeah, this is quite quick and easy example. So you can see you can build powerful connections that on which you can perform similarity search. And even more, if you want to take a look at the knowledge asset, you can always explore it using the DKG Explorer. So if we paste here the URL and go and search for it, you can see here it is as a graph formed or data set that we published. So here is the knowledge asset. Here is, for example, what Umicrol is, possible side effects. So here we can export to the graph, and this is like everything performed on Parch and Testnet. So it's open for everyone. You can right now, without any cost, start playing around, creating your decentralized graphs and perform searches on top of it. And for example, you can see also some of the mainnet examples, like here, Metaverse. And yeah, this is one smaller example here where you can connect different assets, load up them. And yeah, one important component also I forgot is also like the verifiability. So next to that, each asset we will have here the status bar, like it shows us like knowledge asset is created when, what's the state hash, and who is the issuer, who is the owner of that. And in this case, we can see this knowledge asset is created 13 days ago. But for example, yeah, if we go again to the initial one, it was also created and updated 13 days ago, which changed its state hash. And so yeah, we have here available in the repository, the whole example. You can take a look right now and start playing around with it. I think I covered everything at planned, so do you have any questions? Question from Steva. So how are we storing connection between vectors, create a knowledge asset in Infira in Milvus DB? Do we need to prepare something before storing? Yeah, good question, Steva. So here in the preparatory phase, we're generating here as output CSV file, just as an example. And here we are setting up the connections between the URL, section title, subsection title, and body. So for our knowledge asset that we created, we have set up here what's the ID, and then what is the
we lost you again, Nicola, or is it just me?
Yeah, go us, I guess.
I mean, we can see you and everything, we just can't hear you.
Maybe while Nicola sets that up, I can provide context. So for the question, basically, what you've seen, this CSV file is essentially a map between URLs and the content to be vectorized. So when you send that to Milvus, Milvus is going to take that content to be vectorized, and it's going to put this URL and some additional data essentially in the metadata of its own record. So maybe, Nicola, you can show the result of the query of the search. So basically, when you create this first script, creates knowledge assets, and then takes the content of the knowledge asset and basically pushes this to the vector DB. The vector DB takes all of these slices of content, vectorizes it using the model that we set here. And then when you do a search, what does then happen? Basically, the question you pose gets vectorized too, and then it does similarity search, as Yujian explained. And now what you get back is basically an array. There's the array where he mentioned the recall being important, recall being basically the KPI that says what percentage of the results are right in a way. And here you can see the content. This is page content. And then there's the metadata. And in the metadata, we have the fields that are interesting for this example. But the key, most important field, the must-have field here is the URL. So that means if you're building a vector similarity search app based on DKG and you want to take leverage of knowledge assets, obviously the content that you squeeze into the vector DB, you want to show how it comes from a certain URL. And that's where, with this example, you can see, okay, how we feed the DKG, how we feed the vector DB, and then when you do search, it returns the result like this. So that should give the answer, I suppose. I'm not sure if Nicola wanted to add something, and if you can speak or you're still mute.
Still mute.
We don't hear you, man. Still, something's going wrong.
No.
Yeah. Looks like browser having some issues with Zoom. I should switch probably to the application next time. Yeah, I think you covered all, Brandon. So that's what I would like us to say.
Awesome. Feel free to shoot in more questions, folks. I think this was. Yes. Thank you. Any further questions? Feel free to jump in. I'm actually just going to continue sharing the screen so we don't have a lot of stuff left. So basically what you've seen here is the app. This green part is what you've seen. We had two scripts. One was create demo knowledge assets. So it took one knowledge asset, it processed it, and then it created a knowledge asset on DKG through the DKG client. And then it inserted that content into the vector DB. So next time it was doing search, it was all doing this on both. Now, one of the questions that was asked by Tyler was, how would this work on the DKG? And the idea is that you'll be, instead of using one, let's say, instance for your application, just as you actually get the benefits of a shared knowledge graph that we can somehow get the benefits of a shared vector space. And this shared vector space being obviously decentralized. So that's something we will be definitely going much deeper into, and it's a topic of research already being explored quite a bit within Trace Labs. However, when we reach a certain level of RFC maturity, and that is going to be extended to the wider community. So we're going to have ideally an opportunity to collaborate on deciding what's a good update to go there. But that basically, what we're talking about here is OriginTrail V8, and there's a lot of work already being done on that front. So I'm excited that we're making progress, and at some point in the future soon be able to share more. But what we can share today is something that we kind of like overlooked over this whole chat, which is this yellow box here, which is the DKG Python client, which actually hasn't been there until today. So basically, we're here to announce the fresh out of the oven release of the DKG Python beta client. It's still in beta because it hasn't been obviously thoroughly exposed to many applications yet. It's just out, so it needs probably a little bit more time so to figure out all of the quirks and whistles and all of the little details. But essentially, this is what we've used in this example. And the DKG Python client, you can basically start using from today. It's available on the OriginTrail GitHub. So right now, there's two available clients, the JavaScript client and the Python client. And with this, we actually enable all of the popular Python tool suite to work together with the DKG. That was actually a request from the community. So a lot of especially the AI and ML folk are really into Python, and for them, JavaScript was a little bit of a hassle. So one of the reasons why we prioritized the DKG Python client was exactly this. That's not to say that these are going to be the only two clients. There's interest in various different clients. There's interest in a .NET client for enterprises, a Rust client. Java client was also mentioned by several people. So you can expect to see more of that. But also, if you're looking into or interested into collaborating on building clients for the DKG, we will also be sharing a little bit more information on that, because as with any multi-faceted system, we basically need a way to reconcile all the clients. So there's going to be a system which is, yes, PHP client still underway, by the way. It's pretty close to being built, and maybe even Stan can give some more context on that. But long story short, it's the Python client is coming as well, and it's a matter of obviously how do we prioritize these things, but also how do we have rather a reference implementation of the client with reference tests that we can basically make sure that all of the clients act the same way, regardless of the implementation, or more specifically, the implementation language. But starting from today, it's a multi-client world for the DKG V6. So you can start playing around with the DKG Python client. And when I say playing around, you can also try this example. So you can find what we've just seen, literally the same code that Nicola has ran on the ChatDKG repo. If you want to try it out, feel free to reach out to Discord. Maybe you will need tokens for the testnet or some help just by setting things up. Feel free to post a message and we can help you out. All right. Apart from that, as we already mentioned, there's a 1 million track token grant pool for anybody who is looking to build within the framework of ChatDKG. Building ChatDKG, to sort of clarify, is not about us building another, let's say, framework that you download and use, such as LangChain at the moment. At the moment, it's more of a collection of tools, libraries, examples, such as the one that we've seen now. Obviously, this would not be eligible for a grant because it's very simple. It's almost a Hello World-like example. But it's here to give you ideas and to help you go forward into more exhaustive applications. So definitely feel free to reach out. You can also scan the code to go to the ChatDKG website. if you haven't done so already, which is basically the GitHub repo. It contains all of the information on how you can apply all of these examples, and also feel free to post any questions you might want to post also there on the GitHub issues. So think of what is a more appropriate one for a question. Is it GitHub, or is it Discord, or is it both? Feel free. We're happy to engage in this discussion. And then, when I mentioned Discord, if you'd like to, and if you still haven't joined, you should. This is the QR code you can scan with your phone. Like Yujian said, if you have your phone. Not sure if anybody on this call doesn't have their phone right next to them right now. So feel free to scan it, join it, and let's chat a bit more about how we can build all these systems. I see a question coming in. Building clients a part of some grant. Not specifically at this point. So building clients is not something that fits into the proposition of the ChatDKG directly. So to remind everybody, ChatDKG is about building open source tools for basically AI meets DKG. That means that it has to involve either some form of integration with AI tools, such as the one that we've seen in the beginning, which is the CoPilot plugin for DKG, or similar other tools. And it has to, in a way, be geared towards AI developers. Clients are important, but the clients are a little bit more infrastructural, a little bit more lower level. So that's why we as a team have so far built two. Actually, there's more being built. But contributions as through open source contributions, as with any other project, are also open. We'd like to see them. Obviously, you can go ahead and propose any ideas if you might have, or you've been playing around with some code already, but it's not necessarily currently under the auspices of ChatDKG. It's not to say there won't be grants of such nature in the future. However, right now, this is not the focus of this particular call.
Yes.
Okay.
There is one thing which is a part of this open call. It's the OT hub, which
Yes.
we expect to be started or to go into development very soon. I was hoping to see someone from the bunch of guys that are developing the OT hub on this call today, but I guess we didn't have much time to spare for that part. And given that we're expecting a very steep growth in terms of the knowledge base residing on the decentralized knowledge graph, so the knowledge assets, which are essentially sovereigns living in the network, we are hoping to see the OT hub development to kickstart very soon. Now, this is not necessarily direct aid to those who are developing AI solutions on top of the OriginTrail, but it does give the wider OriginTrail community an insight into how quickly the decentralized knowledge graph is growing. And the use cases are growing also with the help of the AI-enabled solutions. Essentially, the sky is the limit, and we're really hoping to see also the OT hub gaining ground very, very quickly for everybody to see how fruitful the DKG has become over the last few months in a very short time since the launch of the Milvus network. Okay, Branimir, will you wrap it up really quickly?
Yeah, we're basically at the end of the program for today, folks. So anybody liking to open up questions or chat, feel free to do so now. If not, we can also close it for today.
On the dot, 7.00 in Europe at least.
Okay. We need an intro and the outro music. Perhaps that could also be financed by through the grant. Yeah.
Yeah. Or Nicola could sing one song.
Nicola could sing
part of the demo
with microphone not working.
It's gonna be the next meetup is code and a song. And there you go. So you'll do some coding and you'll be singing some songs.
Cool. All right, folks.
Awesome, everybody.
Have a good
Thanks
one.
again. See you in a couple of weeks again. We're going to have another really, really cool guest join us. And so stay tuned for that. And if you have, like I said, if you have plans for applying and you're not sure like where to go or how ready the idea is, or is it applicable, feel free to hop into Discord and ask us directly there. And we can chat it through essentially. And we're here to help you. So thanks again, everybody. And yeah, I'm closing it here. Trace on. Enjoy the rest of your week. Cheers.